What's up, Logan? Time for question number 3. Solve the quadratic equation by factoring. Now, the factoring method only works, as with most methods, when you set it to 0. So you're going to want to set these equations to 0. So the first one, where I have x squared equals 13x minus 40, I'm going to get rid of the 13x to the other side. So I subtract it. Oh, the other thing, I like to have the x squared, the a component, to be positive, and that's why I'm moving the other two guys. So we're going to add 40 as well. So we're going to add 40 over there to that side as well. And this gives us x squared minus 13x plus 40 is equal to 0. All right, and now we're ready to factor this thing. So when you factor this, you have to think of all the factors for x squared. That's x times x. That's pretty straightforward. And then for 40. 40, you got lots of different ones. I'm going to go with 4 and 10 first because that's the one that I see first. And then I'm going to check to see if it works. So I set up my parentheses. I'm like, all right, so I know when I factor to a trinomial, I'm going to have two parentheses, two factors. Since there's only one option for x squared, I know that I'm going to put x and x there. I have multiple options for 40. Unfortunately, I only wrote the 4 and the 10 right now because those are the first ones I saw. So I just want to see if they work. And I notice when I multiply here, I get 4x. And when I multiply here, I get 10x. Now, some of you start to realize that the 4 and 10, if it doesn't make 13, then you shouldn't use it. It's not really good when the x squared is not there. So I always go through this every single time. All right, and then you have the addition. All right, and then you have the subtraction. And all you're doing at this stage is just saying, okay, if I take the 4x and the 10x, I get 14x, which doesn't match the middle, so we don't want to add them. And when I take 4x and 10x, I get 6x, which also doesn't match the middle. So if neither of those match, you know that the 4 and the 10 will not work. So we're going to have to get rid of the 4 and the 10, so we erase them. I'm like, all right, so I already know 4, 10 don't work. So I'm like, oh man, that was too much of an eraser. All right, so we get rid of the 4, we'll get rid of the 10. That means that 4x and that 10x are gone. So let's try something else. So 4 and 10 didn't work. Let's try 8 and 5, because 8 times 5 is also 40. And then I'll put an 8 here and a 5 here. Oh, I forgot to erase the other numbers, right? So we're going to add something different and subtract something different. And then, 8x and 5x. Nice. Because that's 13x. And I'm kind of like, yeah, sweet. And then over here I get 3x, and I'm like, I don't care because I already got one to match. So addition just means that the signs have to be the same. Now here's how it works. If the middle is negative, the larger of the two must also be negative. And if the back is positive, then the two must be the same sign. To make sense of that, the only way to get a positive is if the two numbers you're multiplying, 5 and 8, are both the same type of number, both negative or both positive. The only way to get 13x to be negative in the middle is for the larger of the two numbers to be negative, and then noticing that they're both going to add because they're both negative 8 and both negative, it makes sense for the 13. Now, the top of the two signs always goes in the front factor. The bottom of the two signs always goes in the back of the two factors. And then now we solve it from this stage. We go x minus 8 is equal to 0, and x minus 5 is equal to 0. This right here is what we call the zero product property. It just means that when two factors are multiplied to get 0, you know that one of those factors better be 0. Otherwise, this does not make sense. This gives us x equals 8 by adding 8 to both sides. This equals x equals 5 by adding 5 to both sides. And I like to write my answers as this. Small number followed by larger number, just for typing purposes. All right, let's try question number 2. So question B, sorry, not number 2. Question B, we've got x squared. Notice it's already set to 0. X squared plus 19x plus 18 is equal to 0. You can run through all the factors, right? So x times x. I'm going to go ahead and write them all out. We got 18 times 1. That's the one that works. We have 9 times 2. That one doesn't work. And we have 6 times 3, okay, which also doesn't work. Now, how did I know that? Because, well, I wrote the problem. That's one. And then the second reason is because if you take 18 and 1 and you add them, you get 19. So that's a really good indicator that, hey, that's the one you want to pick. So we're going to go equals 0. And we put x there, and I'm going to use 18 and 1. Why won't I use 9 and 2 right now? Well, because 9 and 2 doesn't give me 19. 6 and 3 doesn't give me 19. Right? 18 and 1 gives me 19. So why not use 18 and 1 to see if it really, pans out? So we get 18x there. We get 1x here. And then when you add them, you get 19x. Notice the middle is positive, so you know the bigger number is positive. Notice the back is positive. The back just tells you whether or not they're the same sign or different. So they're going to be the same because the back is positive. The top sign goes to the front. The bottom sign goes to the back. And now we solve it by using the zero product property. X plus 18 is equal to 0, and x plus 1 is equal to 0. Solving this, I get x is equal to negative 18. Solving the second one, I get x is equal to negative 1. And I have my two answers for question B. Moving on to question C, you're going to want to set this thing equal to 0. So I subtract 2 from both sides of the equation. This gives me 5x squared minus 5x minus 2. Okay? All right. So we set equals 0. So we set up our two factors like that. And I'm realizing that this problem probably can't be factored. So we'll talk about what you need to do. I will never ask you a question where it says solve the quadratic equation by factoring and you can't factor it. It looks like I made a mistake on this guy, and that's all. All right, so we got 5x squared minus 5x minus 2 equals 0, and then we try to factor it. So we think of all the factors of 5x squared. I can think of 1, 5x, and x. And then I'm going to practice with the 2. So I'm like, all right, well, 2, there's only one option, 2 times 1. So I go 2 there, 1 there. So I go 2x, and I go 5x. You'll notice that if I add them, I get 7x, and if I subtract them, I get 3x. Neither of those matches the middle, which is what I want to happen. Now, that means 2 and 1 didn't work, so what I'm going to do is I'm going to switch the order of 2 and 1. All right, so I'm going to put 1 in the front, and I'm going to put 2 in the back. Let me change that color up a little bit. So I'll put 1 in the front and 2 in the back. Now, what this does is it's going to give me different products. It's going to give me different products. It's going to give me 1x and 10x. And you'll notice that if you add those, you don't get 7x, and when you subtract, you don't get 3x. You actually get 11x and 9x, which doesn't work. You've exhausted all the factors of 5x squared. You've exhausted all the factors of 2, so this is not factorable. Now, what that means is you must use another technique to solve this thing. My suggestion, just based on what I can see right here, my suggestion is the quadratic formula. Okay, the quadratic formula. Now, on the test, don't expect me to ask a question that can't be factored when I explicitly say factor it. All right, it should be factorable if I ask you to factor it. This was just a really bad question on my part, my mistake, okay? But it does bring up a good point. What happens if it's not factorable? Just use the quadratic formula instead. And when I say just, it does mean you have to take some time. All right, I'll see you guys on question number 4.